Okay, so we ended up last time, we were talking about solving equations, and that's where I want to go back to here and start from there this time. Now, I think one of the toughest skills in math is to take a situation or a set of words and put them into a formula equation. So I want to take a second to look at that before we move on to our solutions and mixture problems. A simple problem, one of the first things we need to do in any sort of word problem is define what our variable is. So let's take a look at a simple problem like, let's say that a CPM machine costs $175 for setup and $75 per day. If the insurance company will only cover up to $850, how many days can it be used? I should say how many days to cut it short. So what we have to do here is we have to write a formula for the cost of this machine. Now, some people prefer to just start jumping in and putting in the numbers. I usually prefer to just write out a formula that describes what we're looking at here. So the total cost, and I usually use words instead of just symbols, is equal to setup plus the daily cost times the number of days. So now here it says it's asking for how many days, so we know that that number of days is going to be our variable. I'll define that to be X. Our total cost, the insurance company will cover up to $850. Setup was $175, and our daily cost is $75 per day. So that gives us our equation now that describes this problem, and all we have to do is solve for X. And as we covered last class, we'd subtract 175, giving us 675 equals 75 times X, and we would divide by 75. Giving us, what does that come out to be? 9 equals X. So what that is saying, now at this point we've solved our equation. We're not done with the problem. We still have to make sure we answer the question that is being asked. This problem is asking us how many days. So we have to go back and say, okay, X is 9 and X does represent the number of days. So the answer to our question is 9 days. Insurance will cover for 9 days. Other equations we can throw in there, or other types of problems we can throw in here might be Pete sells 3 times as many cars as Fred. In a month, where they sell a total of 96 cars. How many did each sell? Now, in a problem like this, a lot of times, again, the important part is labeling it out. The formula we're going to be looking at is Pete's sales plus Fred's sales has to add up to the total sales. There are 3 types of problems we run into, by the way. We have a problem like this where 2 things add up to make a total. We have problems where two things subtract to make a difference. And then we have problems where two things have to equal each other. So this one is that first variety where two things add up to make a total. So now we got to define those two things. Oops. There we go. So let's come back here. The first thing we're looking at is Pete sales. Now let's do Pete and Fred. Label it like this. And the number sold, so their sales. Now here we have two things we're trying to find. And if we were a little bit further along in the algebra, we'd use a system of equations for that. But for now, we're going to try to keep this down to a single variable. And to do that, we have to see if one of them it can be expressed in terms of the other. So here it says Pete sells 3 times as many as Fred. So what that's telling us is if we let the number Fred sells be X or F or whatever letter you want to use, Pete sold 3 times as many. So that is 3X. And that's all we need to know here is how much each of them sell. So we've got 3X, which is Pete's sales, plus X, which is Fred's sales, has to add up to our total, which is now 96. And again, just to clarify what that means, it's a 1X, so 3X and 1X, make 4X equals 96. Now we divide by 4. X equals 24. Now once again, we have to go back and make sure we answer our question. So X equals 24, that's the number, X represents the number that Fred sold. Fred sold 24 cars. We also have to answer how many Pete sold, which is 3X. So 3 times 24, or 72 cars for Pete. A little more complex than that would be something like this. Let's say Tim sells school hat items with the school logo on it. We're going to call them school hats for $10 each, and school shirts for $15 each. Tim sells 4 times as many shirts as hats, for a total of $700. Once again, how many of each? How many of each were sold? So here our formula is the money from hats plus the money from t-shirts equals the total dollars. So let's figure out how to express that. So once again, we've got, this time what we have is hats and t-shirts instead of people. So let's start that. Just hats and shirts. The first thing we can label here is the number sold. Just like the previous problem, one is expressed in terms of the other. 4 times as many shirts as hats. So which one is going to be X, hats or shirts? The number of hats sold will be X, shirts will be 4X, or 4 times as many. Again, we could use H or whatever letter we wanted to. But you'll notice up here, it's not the number of hats and the number of shirts that are added together, it's the dollar amounts from each. Hats were sold for $10 each, shirts for $15. So what we need to have next here is the dollar amount for each. The dollar amount is equal to the price times the number sold. So $10 per hat times X is 10X is the dollars for the hats. $15 per shirt times 4x. 15 times 4 is 60x is the dollars for the shirts. Now those two values are what go in here for the dollar amounts for hats and shirts. So we have 10x, dollar amount for the hats, plus 60x, which is the dollar amount for the shirts, equals 700. Now just like before, 10 and 60 combine to make 70x equals 700, and we divide. So x equals 10. Now again, we have to make sure we answer our question. So x equals 10, that's the number of hats. Shirts are 4 times x, or 4 times 10 is 40, is the number of shirts. Now I'm going to take this same problem and frame it in a slightly different way. So we're still going to have hats for $10 and shirts for $15. But this time we're going to word it like this. Tim sells 50 items for a total of $700. And once again asked how many each. How many of each were sold? So again, we are still dealing with the dollar amount from hats plus the dollar amount from shirts has to add up to the total, the dollar amount total, which will be $700 again. And we're going to describe things the same way again. The difference is we're not given that reference like we were before, where shirts were 4 times as many as hats, or one of them is a certain number of times as many as the other. What we're given here is a total, 50 total items. To use that, we just have to pick one of our items, the number of one of the items, to be X. So I'm going to pick the number of shirts sold to be X. Now, whatever that number is, if we knew there were 20 shirts sold, the number of hats would be 50 minus 20, or 30. But we don't know that number, so the number of hats is 50 minus the number of shirts, or 50 minus X. Again, we could use whatever letter we wanted to in there, but I'm using X just because it's clear. Now, off of that, we have to, just like before, figure out the dollar amount from each. The dollar amount is still price times number sold. For hats, that'll be $10 times 50 minus X. For the shirts, that'll be $15 times X. So now our equation becomes the dollar amount from hats is 10 times 50 minus X, plus dollar amount from shirts is 15 times X equals 700. And like we did before, 10 times 50 is 500. 10 times a negative x is negative 10x, plus 15x equals 700. Combining negative 10 and positive 15x gives us 5x, so 500 plus 5x is 700. And I'm going to assume you guys can solve from there, subtracting 500, dividing by x to get x equals 40. And again, we have to make sure we answer our question. X represents the number of shirts, that's 40. To get the hats, it's going to be 50 minus x, or 50 minus 40 is 10 hats. So it is the exact same problem. Any questions so far? Okay. Well, that's all I've shown you so far is problems where two things add up to make a total. Let's look at one like this. Sam sells 3 times as many cars as Pat. Sam sells 42 more cars. How many each? So again, how many did each sell in a period where Sam sells 42 more? Now in this period, situation, what we have is the number that Sam sold minus the number that Pat sold equals 42, or equals that difference in this case. So it's a subtraction problem. It's a difference in this problem. Now again, we're going to list Sam and Pat. And it's the number sold. And Sam sells 3 times as many. So if we let Pat be X, Sam will be 3X. So our formula is pretty simple. 3X minus X equals that difference of 42. And again, I'll assume you guys can take it from there to get 2X is 42, or X equals 21. And we go back to plug the numbers in. 21 is Pat's number sold. So 3 times 21 is 3 times X is 63 is the number that Sam sold. If we subtract, we do get 42, so we can check to see if it's correct. So with those generic number problems out of the way, let's take a look now at a type of problem that is specific towards, well, not necessarily specific to medicine, but is used quite a bit in medicine. It's actually also very common in chemistry. We're going to talk about solutions and mixtures. What we're looking at here is we're looking at having 2 substances. We're looking at having an active substance, which is a medication of some sort. Let's put A in there. And we are going to refer to that. The generic term we're going to use for medication in this course is just serum. And then there's an inactive substance. The inactive substance is just a filler. Usually it's sterile water or saline. The generic term we're going to use in here, it can be some other inert powder as well if it's in a pill form. Most of your pills are not solid medication. They have some sort of a filler into them. For this class, we're going to assume we're dealing with liquids. So we're going to use NS, which stands for normal saline, or also stands for neutral solution. Neutral solution and normal saline, both of them, they just mean it has no medicinal value. It's just a filler. It's often what we call a vehicle. It carries the medication into the patient. If it's a liquid, of course, you're dissolving that medicine into a liquid, so you can run it into the patient through an IV or through an injection, a bolus or whatever. So anyway, the amount, what we're concerned about here is the amount of that active substance. And the amount of the active substance the amount of serum is equal to the concentration times the volume. Now, it could also be equal to the concentration times the weight or the mass. We're choosing to work with volumes for right now. The concentration is just the percent as a decimal. In other words, it's a rate. Now we're going to ignore a couple of traits about solutions here in many cases. And when it does come up, when it is significant, we'll mention it and we'll work around it with the math. When you add a substance into a solution, it doesn't necessarily conserve volume. Those of you that have had chemistry or physics, the whole idea of conservation of mass is true. Conservation of volume is not a scientific law. If I have 80 milliliters of water and I add to it 10 milliliters of salt, my final substance does not end up being 90 milliliters. the salt dissolves into the water and it actually hides between believe it or not, there's empty spaces between particles of water. The salt hides in those empty spaces and does not increase the volume by the full 10 milliliters. So that whole idea is not true. Now, there are going to be some cases where we're going to assume it over the next several weeks just because it makes the calculations possible. But just a little side note of that in a solution, often that does not happen. In any mixture, that often does not happen. You add 2 volumes and the total volume does not add up. It's always less than the total volume. But anyway, what we're going to look at here now, using this formula, is how much serum or medication is in 400 milliliters of a 24% solution. Well, that amount is going to equal to the concentration. 24% is going to be written as 0.24 times the volume. I usually put the volume in parentheses just because it makes life easier when we get into more complicated formulas. And I'm going to leave the units of milliliters off that for now. So the amount of serum, the amount of medication, is 0.24 times 400, which is going to be 96. The 400 milliliters was in milliliters, so it's 96 milliliters. So there's 96 milliliters of serum or medication in that solution. Now, one thing we can deal with when we're mixing or combining solutions and medications is the amount of serum put in, whether it's a single item or total, is equal to the amount of serum that comes out in the end. In other words, the starting amount of serum is equal to the ending amount of serum. And I know that seems obvious, but the reason I mention is if we're mixing 2 solutions, let's mix 120 milliliters of 68% solution with 60 milliliters of 86% solution. And I want to ask you to find the concentration of that final solution. Find the percent of the final solution. So here what we have is we have 2 amounts of solution. And basically, we're looking at the amount of the serum, really. Amount A plus amount B has to equal that total amount of serum. Well, the first solution that we're combining here is 68%, and we're combining it with an 86% solution and hoping to get a result that we can calculate, that we can find. We know the volume of each. We know that there was 120 milliliters of the 68% and 60 milliliters of the 86%. With that in mind, do we know the volume of the final solution? Now, we said we were going to ignore the issues with this, and because they are both solutions, and we're assuming that the carrier, the filler, is the same, the volumes do add. So 120 milliliters plus 60 milliliters equals 180 milliliters for our final volume. So I'm going to put X in here as the concentration of that final solution. And that's what we're trying to find, is that concentration. So based on what we know about our mixtures and solutions now, the amount of serum in solution A is going to be the concentration of 0.68 times 120 milliliters. Now, since these units are the same all the way across, I'm going to keep the units out of the formula. Plus, the amount of serum in solution B is 0.86 for its concentration times a volume of 60 milliliters. That has to equal the amount of serum in the final solution We don't know its concentration, but it'll be multiplied by a volume of 180 milliliters. So now here we've got 0.68 times 120. Let's try that again. 0.68 times 120. 81.6 milliliters of serum in the first solution. 0.86 times 60 is 51.6 milliliters of serum in the second solution. And x times 180, I'm going to write that as 180 times x. So now I can add up 81.6 plus 51.6 is going to be 133.2. Here's 180x. And now we'll divide by 180 to get x by itself. Getting 0.74 or 74%. So that final solution will be 74% serum. Well, that's a nice process, but generally we're not looking to mix two random solutions and random amounts together and figure out what it comes out to be. Generally, we have a target amount that we're looking for, a target concentration that we're looking for. So we might have, let's say that we have on hand 24% solution and, let's see here, 40% solution. And let's say that we need a 36% solution. So the question we're going to ask here is how much 40% solution do we need to mix with 60 milliliters of the 24% solution in order to create that desired 36% solution. So here again, we're looking at adding the amounts. Amount A plus amount B is going to equal the total amount. Well, solution A is going to be the 24% solution. Solution B is going to be the 40% solution. Those are the ones we're mixing. We're hoping to get a result. In this case, we desire to get a result that is 36%. Now, the only volume that's given here is 60 milliliters of the 24%. So that's going to be 60 milliliters. We are looking for the amount of the 40%. So we're going to let that amount be X. Now, what's the amount of the 36%? Well, if we scroll back up to this previous example, we had 120 milliliters, 160 milliliters. We added those together to get 180. So just the total of those was the volume of our total. The same will happen down here. 60 plus X is going to be 60 plus X. So now we can write our formula. 24% will be a concentration of 0.24 times the volume of 60. Again, that's milliliters, so we're just going to assume all of this is going to be done in milliliters when we get our answer. Plus 40% is 0.40, or just 0.4, times X is its volume, and that has to equal 36% will be 0.36 times, now instead of 60 plus X, I'm going to change that to be X plus 60, just because we're used to seeing it in that order a little bit more. So now we're going to go ahead and combine 0.24 times 60, 14.4, plus 0.4 times x is just 0.4x. Over here, we're going to have to distribute. 0.36 times x is 0.36x. 0.36 times 60, 21.6, so plus 21.6. Now here again we have a variable on each side of the equal sign. So we can't just combine them. In this case we have to get rid of one. I always get rid of the smaller one. In this case that's the 0.36x. So we subtract 0.36x to get rid of that. That'll leave us with 21.6 on this side. Subtracting 0.36x here leaves me with a positive 0.04x, and 14.4 is still over there. Now we're going to subtract 14.4. That's gone, leaving us with 0.04x. Subtracting 14.4 here is going to give us 7.2. So next we'll divide by the 0.04. X equals 180. Now we got to make sure we answer our question. What does x represent? It's the amount of the 40%, 180 milliliters. Is that what we were looking for? Yes. How much of the 40%? Any questions? Now I realize those can be a little tricky, so we are going to do more examples. Today and again on Monday, we'll do a few more examples. Let's do one more example here. In this case, let's say that we have on hand, well, let's just ask the question. Rather than explain it, we're going to just ask, how much 81% solution should you mix with 240 milliliters of, what do I want to put in here now? Let's do 57% solution to create 65% solution. Well, let's start writing this one out, and then we'll go from there. So again, we've got, I'm just going to write A plus B is going to equal our total, just to abbreviate. So we have, what are the 2% that we are mixing? We have 81% and 57%. And we are hoping to get 65%. The volume that we know is 240 milliliters of the 57%. We're going to let the amount of the 81% be x. This will be x plus 240. So now this is 0.81x plus 0.57 times 240 equals 0.65 times x plus 240. So 0.81 times x is just 0.81x. 0.57 times 240, 136.8. Here we're going to distribute again. 0.65 times x is 0.65x. 0.65 times 240. Is 156. So now again we have variables on each side. I have to get rid of one. The smaller one is the 0.65, so I'm going to subtract 0.65x and make it go away. leaving me with just 156 over here. I have to subtract 0.65x from this side as well, which is going to give me 0.17x. No, 0.16x, sorry. Plus 136.8 equals 156. And now I'm going to subtract 136.8. So 0.16x equals 19.2. Dividing by 0.16 gives us that x is 120. Very good. So that means it's 120 milliliters of solution A. Okay, it's getting close. What's that? Is there anybody else that doesn't have school on Monday? Medford, do you guys have school Monday?
Yeah, we have school Monday. We don't have school next Friday.
Next Friday? Okay, Shawamigan, are you guys in next Friday? Okay, so what we'll do is we'll kind of do, since you guys are the biggest group, so we'll work around you. What we'll do is what we cover on Monday, I'll come back on Friday and cover with you guys, kind of catch you up. So those of you in Drummond and Hurley, you'll kind of get doubled up a little bit on Friday, but there'll be a little extra time if you want to bring in other work. You guys don't have school on Friday either? Well, that'll be perfect for you then. So Friday we'll catch Shawamigan up. Okay, homework for you guys to look at. On page 53 through 54. 1 through 15. If you want to just start out with the odd numbered problems for now, these are the mixture problems that we started talking about. We'll just talk about those a little bit more next week. So you guys have a great weekend.